This is thoughtful thinking, and these opinions are mine. And I'm just plain Bill, but I thought this was thought provoking enough that I ought to share it. I never understood mathematics. Maybe it's because I thought I was dyslexic, but this may explain why. And it's kind of on the boring side, so please stay with it and pay attention. I appreciate you watching this and subscribing.
Hey there, technology enthusiasts. Today, we're delving into the extraordinary life of John von Neumann. John von Neumann, born in 1903, was a brilliant mathematician and computer scientist. He made groundbreaking contributions to computer architecture and laid the foundation for modern computing. Von Neumann's concept of the stored program computer revolutionized the way we design and build computers. His visionary ideas paved the way for the computers we use today. Von Neumann's legacy continues to inspire and shape the field of computer science. Join us as we celebrate the remarkable achievements of this mathematical genius.
Hey, so school sucks. Everyone knows it. One of the biggest complaints is that students memorize a bunch of words, and a lot of the time they don't have any deep comprehension behind those words. How many students you see coming out of high school, college even, they can say, oh, E equals MC squared. Oh yeah, I heard that. I learned that E equals MC squared. Well, what does it mean? No idea what it means. Oh, what's the Pythagorean theorem? Oh yeah, that's A squared plus B squared equals C squared, right? Well, no, the Pythagorean theorem is a statement about triangles, and that statement A squared plus B squared equals C squared doesn't say anything about triangles. So all these students learning to memorize things, they don't get the deeper learning. And one of the great challenges in teaching is that any word or symbol can mean many different things depending on the context. So when a teacher defines a new term, the words used in the definition might be interpreted in many different ways, potentially misleading the student in several different directions. This problem is further exacerbated in mathematics, besides geometry, because it fundamentally deals with intangible abstractions. And so anytime a teacher uses a tangible example to demonstrate a mathematical concept, the student might get caught up in the particulars of the example and then fail to learn the concept. So I've heard there was recently a television series called Empire, and perhaps more notable than the series itself was two of its stars, Jussie Smollett and Terrence Howard. Smollett made himself famous by creating an obvious hoax which drew massive media attention from big-name politicians, news reporters, and other morons who were somehow dumb enough to actually fall for it. He's now facing prison time for his crime. Howard, on the other hand, is interesting for completely different reasons. Specifically, he argues that 1 times 1 equals 2. And he coined the term Terryology to describe this unconventional logic underlying his bizarre claim. Howard's commitment to this position seems unshakable. The big question is why, though? Is he like Smollett, simply hoping to boost his career somehow? Well, I can't rule this out completely. I'm just going to explore the other possibility. Maybe he genuinely believes that 1 times 1 is 2. So the first thing we must do to reorient into this bizarro world is to forget the 2. Forget about the 2. Instead, ask, why would 1 times 1 be anything other than 1? And as it turns out, there's actually a very good reason for this. Not a mathematical reason, but a mental, conceptual reason for thinking this way. In order to convey the concept of multiplication, so many examples are used. You can buy 3 six-packs and get 18 beers. You can buy 2 cartons of eggs, supposing you can afford eggs, of course, and get 24 eggs. But in any example we use, there's a unit involved. A beer is a unit. An egg is a unit. And remember, 1 times 1 equals 1 has no units except for the number 1 itself, which is the abstract, purely mathematical unit. Another important way to perceive multiplication is in terms of area and by extension volume. So here I have a very poorly drawn grid of squares. Just pretend that they're squares. So we can use multiplication to count the number of empty squares here without counting them individually. And there are two different but equivalent ways to handle the units here. The first way is to look at a square and say, okay, the units here are squares. Each square is a unit. Just like a six-pack of beer has units of beer, and the grid has units of square, right? Well, the other way to look at it, the more interesting way to look at it, is that the unit square can be broken down into a composite unit by multiplying the base by itself. Or as we say in mathematics, the square of the base. So we can distinguish an inch, a unit of distance, from the square inch, a unit of area. And this is how we get the equation 1 inch times 1 inch equals 1 square inch. So we're combining two instances of the same unit to create a new unit. That's not the case when you're buying groceries. And the point, coming back to Terryology, is that we are in a sense multiplying 1 times 1 and getting something more, something greater, because we've combined units. There is a saying you've probably heard that the map is not the territory. Well, in math, there is no territory. All we have is a map. You look in the world, there are all kinds of units in metrics, but you will never find the number 1. It's always one of these, one of those, one of something. This means that there is no real world example of 1 times 1 equals 1, where the 1 on the right side is the same as both of the 1s on the left side. The map can only be seen in the mind. So maybe Terryology does have a point, because when we have 1 of something, that 1 is in a sense more than the number 1 by itself. I suspect this is the root of Howard's misconception. You still can't get 2 though, unless you redefine multiplication to mean something totally different, but he hasn't done that. So the conclusion is that Terryology is a symptom of the math education crisis. A moderately successful actor who went to college never properly learned the difference between pure abstraction and units of measurement. He also failed to learn, as the vast majority of students these days do, how to structure a mathematical proof, which you can see for yourself by reading his proof that 1 times 1 is 2. Fortunately, we are solving the math education crisis. We know how to do it. If you would like to learn more and maybe even be a part of the solution, go to algebravictory.org. And please don't hate on Terrence Howard for the failure of his teachers, but do hate on Jussie Smollett. He's a criminal and probably deserves what's coming to him.
Appreciate you watching and subscribing. And that's all, folks.